This video is to familiarize you with the lathe parts and the use. General parts of the lathe. The lathe can be broken into some general parts, and we've got the headstock here, and we've got between the headstock and the tailstock over here, we've got the bed, this whole cast iron piece. On top of the bed we have these precision hardened and ground ways, and sliding on those ways we have the carriage, and the whole thing is on a base. If we take a look at the headstock, a little bit more detail here. The headstock has this spindle going through, and you can see the spindle here is hollow. In fact, if I take this piece of stock, if I do this without getting stuck, you can see that the spindle is hollow, so you can put a long piece of stock in from this end, and then you can hold that stock in a variety of spindle nose tooling, like a 3-jaw universal chuck here, and just clamp that workpiece in. In the headstock we have the quick change gearbox for changing speeds and feeds. Your speeds are your RPMs, and they can be set with this set of levers and knobs. For instance, if I wanted 610 RPM on this lathe, that's red, so that's in high gear. You can see the H there. I can throw that lever over to the H for high gear, and then I have a little arrow here which I can point to the 610. If you notice, in order to make this shift between gears, I have to rotate that chuck a little by hand. And you can do that, or you can also use the jog button here. If I just touch the jog, just let it spin, and as it's coasting down, you can shift. Just don't do both at once. Don't try to shift. Don't use the jog button and use your hand at the same time. You don't want to get hurt on the chuck. Also in the headstock, we have the quick change gearbox. And I'll be showing you the other lathe as well, but on this lathe you can see that you can change the feeds per revolution. On a lathe, your feed is given in inches per revolution. So for every revolution that the spindle makes, your feed is going to move whatever amount is on this chart. As we look at this area right here, we can see that we have a choice between cutting threads over here and feeding over there. Some of these icons are a little hard to understand, but you can see that if you turn this on, I can switch between the feed rod and the lead screw. Really shouldn't do it at high RPM. And as I look at the chart here, I have two sides of the chart. First thing you'll notice is you have a little gear configuration here. If you look in the end of the headstock, you pull that plate off, you can see the gears that are there. And there is 127 tooth gear, 120, 50, and 25 tooth gears. And I can tell you right now that we have this configuration, so these two are what we have in the back. You can always check. If I wanted to set this on 6/1000ths of an inch per revolution, I can find 0.006 in this table, in this chart, 6/1000ths, and if I follow over, I see that that's a 4. If I follow up, I see I am in the E column, under the name A column, so AE4. Going to these knobs, I see I have an A up here, A, B, and C. I'm going to turn that over until I'm on the A. It's already there, already on the E, and then I switch over to the 4. So my feed now, if I turn on the machine and start feeding it, it should be feeding the carriage at 6/1000ths per revolution. You also, on the other side here, you have these hole numbers, which are threads per inch. And so if I wanted to set this on 13 threads per inch, maybe to cut a half 13, I find the 13, it's done the same way. 3EA. It's not too far from what we just had, 3EA. Now if I switch this selector over to threading, I can go with threads per inch. So the other one would have been inches per revolution. So you can see that when we're pointing towards the feed, I'll turn on the machine. The feed rod is turning. The feed rod is what supplies the power to the carriage to move it. And if I select the lead screw for cutting threads, I'll turn that on. See how the lead screw is turning. The lead screw is only used for cutting threads. So you have those two options. On some machines you have a neutral as well, so that you're not putting the wear and tear on the parts. Now we're going to talk about the carriage. The carriage is all of this stuff that moves back and forth when I turn the longitudinal hand wheel here, or the carriage hand wheel. At the very top we have the tool bed. that we've ground in a previous video, and you're going to be using to turn your parts. I've got the tool bit clamped in a tool holder. It's held in there, and I can put that in what's called a tool post. In fact, this is a quick change tool post. You'll notice as I move this lever in and out, we have a little plunger that pushes forward or back, and it locks the tool onto the dovetail. And you also see a little adjustment knob here for the height of the tool. I can adjust that, so I can take it on, take it off, put it back, and it goes right back to that same height. It's a big improvement over the old tool post. That goes onto a compound rest. The compound rest has a T-slot in it, and this nut pulls up the stud which goes into the T-slot and clamps it into place. The compound rest can be, you can loosen these two socket head cap screws and swivel this to different angles, 360 degrees, and that is fed by hand. You turn this little hand wheel here and it moves it in and out, and it doesn't have any power feed. That goes on top of the cross slide. Cross slide allows for your X moves in and out towards the axis or away from the axis. And that slides on a dovetail. And this is the cross slide hand wheel, and on that we have a micrometer collar. We'll show you in a little bit. And then you have the carriage hand wheel, which moves the whole carriage back and forth longitudinally, which is also the Z direction on the lathe. Typically you don't have a Y direction on the lathe. We have a variety of controls on the carriage. One is the switch to turn it on. We lift up on that switch, turns it on forward. If we push down on it, it turns the lathe on in reverse. And right in the middle is off. You do have to be a little bit careful on some of the lathes that you don't go right from forward to reverse. I'll show you. It's not necessarily good for the lathe, but on some lathes there's even a delay there, where you have to wait for the servo to reset, and then it will turn on and you don't expect it. This lathe is not bad that way. So that's turning the lathe on and off with that carriage control there. And as we look a little more closely at these other controls, these are our feed control knobs, and this is our threading lever here. For the feed control, the bottom knob on this lathe turns the feed on or off. Wiggle a little bit. That engages the feed, that disengages the feed. The top knob either engages the cross feed or the longitudinal feed. Right now with it pulled out, you can see the little picture here. With the knob pulled out, it's showing you a cross feed symbol. So that means I'm engaging, right now that would turn on the cross feed. And if I switch to longitudinal, now that would turn on the longitudinal feed. So this is on and off, and this switches between the two. And I'll just show you that running here, make sure I'm clear of the part. Turn the machine on, and you can see the feed rod is turning, which means the gearbox is providing the power for the carriage to move back and forth. If I pull out on this knob, you see now I'm moving longitudinally. The entire carriage is moving. You turn off the feed. If I pull out on that knob, I switch from longitudinal to cross feed. Now I can turn on my cross feed. See it's feeding in. This lever on the carriage, by the way, this part that hangs down from the carriage is called the apron. It would hang down in front. And there are two more things on that I wanted to show you. One is the half nut lever, or the threading lever. I'll turn on the machine and you'll notice that I'm going to select the lead screw for cutting threads. Turn on the machine and now you can see the lead screw is turning, which is going to provide the motion to the carriage to move. If I engage this half nut lever, notice the carriage starts to move. I can lift up on it to disengage it. You'll also notice that we have a threading dial, or thread chasing dial, some people would call it. That's numbered 1 through 4, and it's got half marks there, little indicator there. That's so that when you go back to take another cut in your thread, it maintains the timing between the spindle rotation and the location of the carriage. So that when you go to cut your thread, you cut back in that same groove rather than cutting a thread between the original groove. You can see here, if I wanted to do it, I did it on the number 2 every time. I can just engage it when it gets to number 2, and that dial stops rotating as soon as we engage the lever. Disengage the lever, it starts rotating again, it tells us when we have the proper timing to engage the lever again. Now on most lathes, if you're cutting an even number of threads, you can engage on any of those lines. For an odd number of threads, you can engage on either the numbered lines or the unnumbered lines, any of those, and you'll get back in the same groove. For a fractional number of threads, like say you're cutting 4.5 threads per inch, you want to always do the same line. On these lathes, always just do the same line. It's slower, but I think because they've converted from metric to English, we can't trust that the old system works. So now you know what most of the things are on the carriage. One more thing I'll point out to you is the carriage block. And on this lathe, you have a little square screw here, square-headed screw. As you tighten that with a wrench, just snug it. You don't want it super tight because those screws are pretty small; they can break. Snug that up. That locks the carriage. That locks the carriage to the waves. You can use your adjustable wrench for that. Also want to show you the feed reverse knob. The feed reverse knob is right here. That allows you to cut either from the right to the left or the left to the right, or from in the in direction or the out direction with a cross slide. It changes the direction of rotation on either your lead screw or your feed rod. I'll show you that now. If I turn the machine on, you can see that the feed rod is turning and the top is going away from us. And I'm just going to turn the machine off as it coasts down. I'll change that. You can see the direction of the feed rod is now changed. The top is coming towards us. And if we engage the power feed now, we can see that the cross feed is going in. And if I reverse that feed, engage the cross feed, you can see now it's coming out. And the last thing is if I just show you the cross feed, I engage the longitudinal feed. As I engage the longitudinal feed, now you can see it's going clockwise, which is moving the carriage away from the headstock. And if I change that direction, you'll see now that it's going towards the headstock. And of course, I'm going slow enough now so I can show you this. You can see that the lead screw is also going to reverse directions when I do that. Normally you would turn the lathe off to do this. If you're going at a very slow RPM, you can get away with it. So that's the feed reverse knob. Next, I'll show you the tailstock on the lathe. The tailstock slides on the ways and moves parallel with the axis of the lathe. In fact, the axis of the tailstock is normally in line with the axis of the spindle of the lathe. And you can see when I turn this hand wheel here, it moves this tailstock spindle or ram in and out, and that's marked off in inches and millimeters. I also have a micrometer collar on this, so I can tell. I just move that out 10,000ths of an inch. I just move it out 1,000ths of an inch. And you can lock that tailstock to the ways so it won't slide back and forth with this lever in the back. You can see it, it's right there. And then you can also lock the tailstock ram with this lever. That locks that in place so the tailstock spindle or ram doesn't go in and out. But why do you even have a tailstock? Well, there's a number of reasons to use a tailstock. One is to use it with a live center. If you notice, this is a 60-degree hardened steel point here. That will go into the end of a part that's been center drilled to accommodate that. It's got a little hole in the end of it. And it will support the end of your stock. So your stock isn't vibrating and moving around if you have a long piece of stock there. So supporting your stock is one reason for a tailstock. Another reason, if you notice, I can back this out, knock this piece right out, and drilling holes is another reason. To drill that center hole or to drill any other hole. Drilling, tapping operations can be done by putting this in the tailstock. I'll show you how to do that. If you notice, these tailstock tooling here have a Morse taper on them. This is a number 3 Morse taper. A Morse taper has about a 5/8 taper per foot, 5/8 of an inch per foot on the diameter. It's a self-holding taper, and this also has a tang on it. So when you put it in, you always have to find where the tang alignment is. On a lot of lathes, it's with the tang vertical. On these lathes, it's with the tang horizontal. So I can see that that'll slide in. Now to make that stay, you just whack it in there like that, loosen the lock, and you can see that now I've attached that into the spindle. That just holds just by friction. In order to get it out, you back up the tailstock, and make sure you're spotting your tool so it doesn't fall on the ways, and you can slide it right out. So there's the tailstock. The tailstock can also be adjusted from side to side, and you have some adjustment screws here, and we might talk about that a little bit later on. So I mentioned in the carriage, this is how you turn the spindle on, lifting it up for forward and down for reverse. You should also know that there are several ways to turn the machine on. So if I lift up, the first way as I showed you is to just push back down on it. Another way to turn it off is to step on the foot brake. So I'll turn that on. If I step on the foot brake, it kills the power and it breaks the spindle, stops it from coasting. You should always remember to turn off the handle whenever you do that. In fact, you can't turn it back on until you do. Always remember to turn that off. Another way to turn it off is in an emergency. Hit the emergency stop button right there, and that will kill the power. Again, you want to make sure you turn off the power to the handle. And to reset it, you don't pull out on this knob. In fact, they're quite weak, these knobs that came with the lathe. Just give it a twist clockwise, it'll pop out. You hear the relay reset in there, and that's your 3 different ways to go ahead and turn that off. A couple other safety issues to mention. You can also make the spindle turn on with the jog buttons we mentioned earlier. A lot of times when I'm doing setups, I will slip my gears for my spindle somewhere into neutral. Well, there is no neutral position here. It doesn't have an N or anything on it like that. But in this case, if I slip between high and low gear, that makes it so the spindle is neutral. And even if I turn the machine on, say somebody were to turn it on by mistake while you're doing some setup here, you don't have to worry about getting hurt. On the other lathes, I think it's the middle lever. If you throw that in between, it'll be in neutral. So those are the 3 ways to turn off the lathe. I also wanted to show you the digital readout. The digital readout reads out the actual movement of the carriage. As you move the carriage back and forth, you should be able to see that the Z position is changing. The Z axis is parallel with the axis of the spindle. And as I move the cross slide in and out, you should be able to see that the X axis is also changing, which is referring to your diameter. And digital readouts could be probably a whole video in and of themselves, but in general, what you'll be doing is probably when you get your tool at some reference position, perhaps at the end of your part, then you can zero your Z axis, and you can make your cut, make a diameter that's 1 inch long. You just machine until you get to 1 inch, and you're all set. And on your diameter, make a cut, you measure it, and then you can go ahead and type in that actual measurement. So if I get a diameter of 0.325, I can enter it right there with my tool right at that position. And then I go ahead, if I take it down to 300 thousandths, I just go ahead and crank it to 300, engage my feed, and make that cut. So the digital readout is going to be very handy for you. This is a 3-jaw universal chuck that's currently installed in the spindle. And what makes it a 3-jaws, it has 3 jaws. What makes it universal is as you tighten the chuck, the jaws move in together. As you loosen it, they move out together. There's something called a scroll plate in there. It's a spiral that causes these to move in and out together. And you can put your workpiece in this chuck, clamp down on that workpiece. This is a wood shop, so you want to make sure everything is good and tight. Metal cutting takes a lot of forces. That's a 3-jaw chuck. Now I'll show you how to change the spindle nose tooling. And you always want to use something to protect the waves. The waves are very important. If they're damaged, you've pretty much ruined the lathe because the whole precision of the lathe is based on it. So you're going to put under here either a cradle or a board. A cradle is just cut to fit right in. A board will also work. So if we do accidentally drop something, we're protecting the waves. Okay, to take this off, first I'm going to put it in neutral as I showed you before so the spindle turns easily. And I'm going to loosen each of these 3 locks. So I'll put my wrench on here. I'm going to loosen that lock. And there's a little witness mark on the top of that mark. And I want that to line right up with the mark on top. It won't come up. You can go beyond that. You can go counterclockwise beyond that, but the chuck won't come out. So you want that lined right up. There's 1. Back up. Oops. And there's 2. And I'm going to spot this as I get that 3rd one, just to make sure it doesn't drop. There's the 3rd one. You can see the chuck is starting to loosen. If it doesn't loosen, you can just give it a little tap. Sometimes it's stuck on there a little bit. Use both hands, spot it, make sure you have the weight of it, and slide it off. And as I take that off, and when I just set it on the bench, I'll show you what's there. You have these 3 pins on the back, and they're notched. Inside of the spindle nose, when you turn that, there's a cam that locks those pins and draws them into the spindle. That's what locks it. And then you have a taper here. This internal taper matches up with this external taper here, and that centers the chuck. And when you put these things on, you want everything to be very clean. So if there are any chips on there, you clean them off with a brush first, and then you can take a rag and just wipe everything off very, very clean. If you have any chip in there, when you install this, it's going to wobble. You got a 10 thousandths chip, it's going to wobble 10 thousandths here, but it's going to wobble 20 thousandths out here. You're going to get a lot of wobble. Plus you're going to have to damage the surfaces here that made up. So we get those clean. Now I was taught to use your hand to get the dust from the rag off. So we try to get all that off of there. And to reinstall it, just reverse the procedure. Make sure those 3 pins line up. Always use the board or the cradle. Slide it on, hold it in place, and tighten it with the chuck key. Of course, you never want to leave the chuck key in here any more than you want to leave it in over here. So I'm going to go around, tighten all 3 of those. And that's how you remove and install your tooling on the spindle nose. After you're done, it's ready to use. So for spindle nose tooling, in addition to the 3-jaw universal chuck, you've also got a 4-jaw independent chuck. And if you notice here, as I put the chuck wrench in, I can turn that. Only 1 jaw moves at a time. That's why it's an independent chuck, and it has 4 jaws. We also have face plates, and you can see those attached to the spindle nose the same way as the other chuck. And the face plate allows us to clamp workpieces directly to the face plate using these T-slots with T-nuts and studs and various clamping hardware. And then we have a drive plate, which is used for turning between centers. And the only thing that's really used on this is this little notch. It drives the tail of a dog. We'll talk about that a little bit later. Okay, now here's the tool bit that we ground in the previous video. And I'm going to show you how to use that to do your checkoffs on your lathe. And we're going to put it in that tool holder. Go ahead and put it in the tool holder. If you notice, there are set screws that I can tighten. These set screws use a 3/16" Allen wrench. Tighten them here, you can tighten them on the tool post. They want to be good and tight. I'll slide that down the dovetail of the tool post. And you notice it stops with this height adjustment here. And then I can lock it in place. I'm also going to install my workpiece. So I'm going to put my workpiece, make sure my jaws are clean, there's no chips in there, I see they're nice and clean, slide my workpiece in. I always want to be very careful with that tool bit once it's installed, not to accidentally bump it. If you bump it, you can hurt yourself. I'm going to tighten this up. When you're doing machining on a lathe of a part that's unsupported on one end, it's just cantilevered out here, you don't want to have that sticking out more than about 3 to 5 diameters. 3 diameters, you're usually pretty good. It's rigid enough, otherwise you get that diving board effect and you're going to get chatter. You're not going to get a good finish. Next I want to set up my tool bit so I can not only face but also turn to a shoulder. So if you notice, you can see that tool. When we ground the tool, we made sure that that angle was less than 90 degrees. And the reason why is because we want to be able to come in and touch off on the end here and face. And we also want to be able to come and touch on the diameter, not have the end rub, and be able to go right up to a shoulder and face out and make a square shoulder. Now, the angle on this isn't too bad. I might want to change it just a little bit to give you a little bit more clearance, so I'll show you how to do that. Here's the tool post, clamped to the compound. If you loosen this nut, notice when you loosen with an adjustable wrench, you should always apply the load as I'm doing now. Always apply the loads, this pointy thing, think of it that way. You're always applying the load in the way that's pointing. That way you put more of the load on this jaw rather than the movable jaw. So I'll loosen that nut. Now you can see I can swivel that all around. In fact, I'll just go ahead and show you. Here's the T-nut right here, and there's the T-slot that slides in. So when you tighten those two, it gets clamped in between. You always want those clean too, because any chips in there are going to make it spongy, not as rigid. So put that back in place. Now you want to always engage the T-nut fully within the compound. You don't want it overhanging like that, where the compound can break off. It certainly won't be as rigid. So now you can see that I can come in here. Students always ask me, well, what angle? Well, you're pretty much just going to eyeball it. I don't know what angle it is, but I know that as I look at this, I've got a certain amount of range that I can go before the end of the tool starts to rub on the part. And I have a certain range I can go over here before the side of the tool can rub on the shoulder. You're not going to generate a surface on your part with an entire edge. It's just the point of the tool that generates that and the movement of the tool. So I want somewhere in between there. Don't know what that angle is, I just know it's clearance on both sides. That looks good. So now I'm going to go ahead and tighten that. So I'll get my hand, tighten it. All right, fully engage your wrench and lean on it pretty good because there's a lot of cutting forces here. All right, now I can get to the end of the part, the diameter, and the shoulder, no problem. So let's show you how to do a facing operation. Now in order to face, you're going to have to get into your toolbox and grab your steel rule. Your steel rule, right here. To get your tool bit on center, which is critical for machining properly, I'm just going to pinch that steel rule between the workpiece and the tool bit, lightly. You don't want to do it hard, it will break the end of that tool off. And then I'm going to view this steel rule from this angle, standing behind the tailstock. If it's vertical, my tool bit's on center. If it's leaning one way or the other, it isn't. Right now it's leaning this way, which means my tool has to be lowered down in order to be on center. So in order to lower it down, I'm just going to back up the cross slide a little bit, loosen the quick change tool post, and lower that nut a little bit. Relock it, don't forget to lock it. Make sure everything's clean, and pinch it again. And I view it from the end, and that's not too bad. It's pretty close. I'll do it one more time, just a little more. That looks good right there. Alright, so now we've got our tool to the proper angle for turning a diameter and for facing, and we've also got our tool on center, up and down, so it will cut properly. If it's too high, the end of the tool is going to rub. If you're too low, your part's going to want to try to climb up on your tool, and it isn't going to shear the material properly. So now I calculate my RPM, which is 4 times the cutting speed divided by the diameter. And for this, it would be about 700 or 800. 4 times the cutting speed for steel would be about 90, and this diameter is about a half, so it's going to be somewhere in the 700 or 800 range. I'll set my RPM as I showed you how to do before. The closest I can find to that without going over is about 610. Alright. Okay, to face this part, I've oriented my tool at the proper angle, this way, and I've set my RPM up, 4 times the cutting speed divided by the diameter. I've turned it on, pull my tool in until it just touches the end of the part. And now if you're keeping track of how much you're removing, you can use your digital readout. I'm just going to move it over a little bit more, and I'm going to lock my carriage lock. I want to make sure that that is locked so we don't end up with a concave or convex surface. We want the end of that part to be flat. If the carriage moves during the cut, it won't be flat. I'm going to set up for cross feed, turn my lathe on. Now you can see I face the end of my part off. You may also see there's a little tiny bit of a nub there. I didn't quite get my vertical adjustment right, so I'm going to just make a slight adjustment here. And there it goes. You don't want to go too far past center because the workpiece is rubbing on the tool and the forces change from down to up and it can break the end of the tool off. So you want to stop it somewhere near the center. And another good idea at this point, if you're going to be turning the diameter to a length, is to just go ahead and zero your digital readout right here. And now you're at your zero position for your part, Next, I'm going to show you how to turn down the diameter. In order to turn down the diameter, I have to change my feed from cross to longitudinal. And then I'm going to go ahead and turn it on and make just a small cut so I can get a measurement from there. Now right there I'm going to take a measurement, and I'm not even going to move the tool. I'm going to leave it right there. I turned my feet off first, and then I turned off my spindle. Make sure everything is clean. Your mic will measure about 10 times more accurately than your calipers, so if you're trying to get closer, you'll have to read your micrometer. So I got a particular reading there. I got 502 thousandths. If I was going to take that down to, say, 495, I could right now. I could type in x.502, enter, and now my digital readout matches my diameter of my part. I'm going to go ahead and take that to 495. Now to get my length right, I'm looking at my z-axis on my lathe. I'm going to just feed that last little bit by hand until I get the length that I want. I'm going to shoot for 475. I'm going to lock my carriage. What I would do before I face that, I would go ahead and measure my diameter first, to make sure my diameter is where I want it to be, and I get 495, about half a thousandths under actually, but about 495. Now I have to reverse my feed so that it feeds out. If you remember when we faced last time, it was feeding in. So I want to make sure I reverse that feed at this point on these lathes. Some lathes, they're not that way. If you cut to the left, it will feed out at that same setting. But if you don't want to plunge into your part, you have to remember to reverse your feed. I'm going to change from longitudinal to cross feed. And engage your cross feed and face that shoulder to length. That looks good. So the next thing I'm going to do is I'm going to go ahead and deburr that part. And when you file on a lathe, remember from the safety, you always hold the file in your left hand so that you're not reaching over your rotating chuck if you're holding it in your right hand. So now go ahead and just touch those two corners there, just to knock those burrs off. And that feels like it's adequate. So we've got our diameter right. The next thing we could check is we could check our length. And our length can be measured with your digital calipers. Take my digital calipers. I'm going to just clean the surfaces, close it, turn it on, and zero it. And I'll use my depth measurement here. Hold it right against that diameter. Check my depth. And oops, that depth comes out to what we intended it to be. So that's facing, turning the diameter to size and to length, and facing that shoulder. Next I'll show you a little bit about roughing and finishing cuts. Something that students do commonly is they'll take a lot of very small cuts to remove a lot of material. In industry we don't do that. We take off as much as we can. We don't care what the finish looks like in between. We just want to have that final finish be within spec. So I'll show you here a roughing cut. I've got my feed set at about 10,000ths of an inch per revolution. I'm going to take a depth of cut. Now, these lathes aren't too big, so we can't be taking an 1/8 inch depth of cut, but we can probably get away with 50-60 thousandths at least. And I'll take that cut right now. Bring this in. Make a little touch off here. And then I'm going to go ahead and move in on my diameter. I'm going to move in maybe 70 thousandths. You see here I'm making a roughing cut. The chips are coming off, they're curling around, breaking off. It's a little heavier right here. There's number 9 chips. So I've just made a roughing cut. And if I had to take this diameter down to this diameter, I would keep making cuts like that until I got quite close. Now, you do have to be a little bit careful. You can't just take a measurement here get some reading. So you get 899,000. So if you wanted to take that down to 500, you can't simply subtract that amount, 499, and get down to 500. There's a number of reasons for that. One is when you're roughing, you have a very rough surface here. Your peaks and valleys are deep, and if all I did now is take and switch to a finish pass, I would make another cut there. Not just because of the peaks and valleys, but also because of the deflection of the tool. So what I would do instead, I'm going to turn this back on and bring it back. You watch I take a cut as I bring it back, a little bit of a cut, just a little bit as I bring it back, and in order to figure out how much further I need to go, I'm going to take a trial finish pass. To take a trial finish pass, I'm going to put it on my finish speed rate. Oh, I'll choose maybe BD4, which is about 3/1000 of an inch. I'm going to make some cut that I know is going to leave my part oversized. I'm going to make a cut. So now I'm making a finish cut. I'm calling it a trial finish cut because I don't even have to do the entire piece. I just want to do enough to get my micrometer on there. I'll kill my feed first, turn the machine off, I'm not touching my tool, my cross slide at all. Make sure there's no little fuzzies on there, nothing to interfere with the reading. Then I take my reading. Now I can get a true reading of what that's going to be. And I get some readings, so I need to take another 10 thousandths off. Okay, now I can just take and bring it back, dial it in my 10. Now I can take my actual finish cut. But you want to make sure you have that trial finish cut in between the two. Otherwise you're going to undercut every time. You think something's wrong with the lathe? Nothing wrong with the lathe, it's just that you don't have the procedure down right. Next we want to center drill the end of the part. This is a center drill. The center drill has a 60-degree included angle on both sides here. They come in different sizes. This is a number 4 center drill, which means the outside diameter of the body is 5/16. The outside diameter of the tip is 1/8. They do come in different sizes. And we center drill the end of the part to produce this 60-degree conical hole here, which we're going to use later to support the end of the part. So we're going to install the center drill in the drill chuck. I've shown you how to install that already. Tighten that up by hand. I'm going to use the chuck key. Go ahead and tighten that. I'm going to change my RPM to an RPM consistent with this diameter, so 4 times about 5/16. 4 times 90 divided by about 5/16. So I'll set my RPM where I want it. There's the RPM all ready to go. Next thing I'm going to probably do is grab just a little bit of oil. A little bit of oil will make a difference in drilling. But just a drop of oil on the end of the part, maybe a drop on the end of the drill bit. The oil will lubricate so that the chips flow out, will generate less heat, you'll get a better finish. What you don't want to do is be drilling this and have the chips stop flowing out. The chips will plug up the flutes, those grooves in the tool. They'll plug them up and then they'll rub and heat up and expand, and the tool will seize up in your part and break off. We don't want that. So I've got the tool installed. I'm going to slide it towards the part. And you want to be careful not to push it real hard and get too rambunctious, because it'll run right into the end of your part. I'm kind of putting the brakes on as I'm pushing here. Get it close. And now if you can see the whole tailstock now, I'll show you that you have to lock the tailstock next. And the spindle lock has to be unlocked. And you can see I can feed the drill in and out with this hand wheel. And as we drill, we're going to drill until we're about halfway up that taper. So I'm going to go ahead and turn this on. Stand aside so I don't get hit in the face with that oil. Turn this on. I'm going to start the drill. It looks good. Now, if you cut a little ring in the end of your part, you scratch a little ring, that means your tailstock isn't on center as far as the alignment in and out here. You have to adjust that. But it's drilling nicely, so I'm going to go ahead and start the drill. As I'm drilling, I'm going to back out, let the chips clear. That's called a pecking motion. I'm going to keep pecking my way into that part. I'll clear those chips out so you can see it better. so deep so that if you start turning your diameter down, you run into that center hole. For most of the things you're doing, probably halfway in there is going to be adequate. So I center drill that hole, back out. Now we can use that hole. If I wanted to drill a hole in that, that would guide that hole, it would align it, make sure it stays centered. Or I can use that hole to support the end of my part, which I'll show you next. So now I'll take the part out, and I'll show you that hole that we just drilled. There's the center hole, and you can see it's a tapered hole. Originally, that 1/8 inch hole that goes straight in was as a grease reservoir. In the olden days, they didn't have ball bearings in their live center, or they're called dead centers, in fact. So you had to put grease in there, and that little reservoir allowed grease to kind of stay in there so it wouldn't seize up. There's the hole. What I'm going to do now is I'm going to slide this out further, like I might have to do if I was turning down a longer diameter or some other operation. I'm going to tighten up that chuck, and then I'm going to change my tooling. I'll take my center drill out. And remember, you always want to clean those off before returning them to the tool crib. And to change the tooling, I'm going to back up my ram and my tailstock. Drill chuck comes right out. I'm going to replace that with the live center. Live center also has the Morse taper, and it's got ball bearings. You can see I'm turning this now. That's what makes it called a live center, as opposed to a dead center, which wouldn't have the ball bearings. So make sure that's all clean. You have to also make sure this is sticking out enough so it doesn't bump the part of the tool that knocks this out. Slam that in. We've got our live center in place. I'm going to bring the tailstock up, and probably have to readjust this later, but I'm going to just show you. I'm going to lock the tailstock, and I just want a little bit of a snug here axially, and you lock the spindle on the tailstock. You don't want it too tight. As this part heats up, it expands, and it's going to push even harder on these bearings, so that can do damage. So if I had to turn down a diameter now, I could throw that same tool in place. Let me show you. I'm guessing we're going to have a problem with this, and I'll show you now so that you'll know what to do with it. If I wanted to turn this diameter right now, if you notice, my carriage runs into my tailstock. Not only that, my tool post runs into my center, or it's about to, right in the middle of the cut. So to get around that, what I do is I take and I loosen everything. I'm going to go ahead and just loosen the tool bit. And then I'm going to loosen the tool post. Getting those two loose will allow you to adjust them until you can find some compromise that allows you to get in there. Now, I'm guessing right now I'm probably going to need to extend this tailstock a little bit more. You don't want to extend it any more than you need to, because the more it sticks out, the less rigid it is. So I have to extend it some. So I'm going to lock the tailstock, apply a little bit of pressure, and lock the tailstock spindle. Now you can see I can get to the end of my cut. I can come into the depth of my cut. If need be, I can put the tool in at a slight angle in the tool holder here, and I can rotate the tool post. So that's looking pretty good. Let me stick it out. You don't want the tool bit sticking out any more than it needs to. That looks pretty good right there. So I'll just reverse that procedure and tighten the nut on the tool post. And then I'm going to go ahead and tighten the set screws. And I want to make sure you get them good and tight. Also, when you're tightening these set screws, make sure there aren't any chips in the holes, because if there are, when you go to tighten it, you'll round those sockets right over. And there I am. I'm good to make a cut. So I just wanted to show you that that's one issue you might run into, is trying to get your tool positioned for the cut. Okay, next I want to show you how to cut a thread. And for your checkoff, all you have to do is set up the cut a thread and make a scratch cut. So you don't have to cut the entire thread. You want to start by setting your compound to the proper angle. And the proper angle for the compound cutting a unified national thread is about 29 degrees from a perpendicular to the axis of the part. Okay, so Here's the perpendicular, so we're going to swing the compound to the right about 29 degrees, 29 and a half degrees. So in order to accomplish that, we have to loosen the two socket head cap screws that clamp the compound in place. And once you've done that, you can swing that compound to different angles. And on most lathes, when you put it at 90 degrees, you either see a 0 or a 90 lined up there. And then you would swing this 30 to 29 degrees from there. Unfortunately on this lathe, the scale doesn't go that far. So what I do is I use what's called a center gauge. We're going to need that anyway to cut the threads. A center gauge is comprised of a bunch of 60-degree angles, which are lined right up with the tool, bisected by the center line of the tool. So we take that center gauge, and if I place this right on the side of the compound, I can sight down the edge of the center gauge here with the edge of the cross slide. As I sight down there, I can actually pretty accurately line that up to 30 degrees. It's half the 60-degree angle that I'm hanging on to right now. Then I'll just give it just a tiny bump to make sure it's just a little bit less. It'll be good enough, especially for the checkoff that you're doing for me. So I've got the compound angle set. I need to tighten it. That's the first thing we do, set the compound. It's easy to forget that and get everything else set up, and you have to start from scratch. So I'll tighten the compound. Good and tight. On these, the first three lathes in the shop, from this plane up, everything's English, SAE. From this plane down, everything is metric. So if you're using your wrenches, Allen wrenches, just keep that in mind. On the 5 newer lathes, everything is metric. Now that we've got that set up, we're going to go ahead and use our threading tool. Now, this particular tool can be used for threading. It's not really a threading tool, but the important thing here is that it's a 60-degree included angle. So we have a 60-degree included angle on that tool. I'm going to put this down, lock it in place. And just like turning on the outside diameter, we're going to check to make sure that that tool is on center vertically. Go up against my diameter and check it. As I view it from the tailstock end, if that steel rule is vertical, we're on center. If it's leaning this way, we're above center. If it's leaning, the top is leaning towards you, it's below center. That looks good. So I'm going to lock that in place. Next, we're going to take and loosen the tool post so that we can align the tool bit. The tool bit has to be square to the workpiece, square to the axis. Otherwise, your threads are going to lean. So I'll try to put my hand where you can see. I'm going to hold the center gauge. Maybe I can hold it over here so you can see better. Hold the center gauge. I like to hold it against the tool, and then move the cross slide in as necessary. And I align that until that edge of the tool is parallel with the part. You could hold it against the part, but you really magnify the error if you hold it against the tool and use that long edge against the part. That's lined up pretty well right there. Again, if we don't do this, our threads will be slanted one way or the other. We want the bisector of the included angle to be at a right angle to the axis. Yeah, that's the boring way of saying it, but mainly we just don't want the threads to be slanted. So we're going to go ahead and tighten that compound right there, the tool rest right there, tool post. And it's always good to double check to make sure nothing moved. That looks good. So we've set up our tool height on center, and we've set our compound angle, and we've set our the angle of our tool. Next, I'm going to go ahead and loosen the micrometer collar on my cross slide. And that's right here. That's a metric Allen wrench. You could say 3 millimeter. So you can see now the micrometer collar turns freely independently from the hand wheel. So what we're going to do is slow the RPM down, like we've shown you before. I'm going to put it on a fairly slow RPM. I think 175 will be okay for this demonstration. If you don't have, if you need to have more reaction time, just slow the RPM down even more. You also want to make sure that when you turn on the lathe, you're on the lead screw rather than the feed rod. So we selected to cut threads over here. And you want to make sure that it's cutting in the right direction with your feed reverse knob here. Then we'll take a closer look at the quick change gearbox for setting up and cut the threads. And you can see here a couple of charts. One, as we talked about before, has the feeds. The other one has the feed rates. The other one has the threads per inch. And we want to cut 13 threads per inch today. So I find 13 in here. And I see that lines up with 3EA. So I come up here and I find the 3. I find the E right here. And there's the A. Some of these arrows have come off long ago, but you can always count where you are to find where you need to be. So if we turn that on now, we should be able to see if the lead screw is turning. And we're ready to cut the threads. Okay, after setting up your quick change tool post, your quick change gearbox, I set up my gearbox to 13 threads per inch. I've made sure my feed selector is on thread cutting rather than feeding. And I've set my RPM quite slow. The reason you set it slow for a manual lathe is a couple of reasons. One is your reaction time. You have to be able to disengage that thread at some point. And if you're going too fast on an RPM, your carriage is moving kind of fast. The other reason is there's a fair amount of surface area in contact making that cut. If you're cutting too fast, you'll get a chatter. You get a friction, you'll get a bad finish. One thing you can do that can help out is you can put some blue dye on there, dye can, or you can just take a Sharpie and make some marks on it like this. Hopefully this will help it show up on the video as well. You don't necessarily have to do that, but it can make things a little easier. The next thing I like to do is get my compound. I don't like to have a lot of overhang on my compound, so I'm just, where my fingers are right here, I'm just making sure that the compound isn't overhanging too much. Again, we're trying to avoid that lack of rigidity that you have in a diving board. And I'm going to zero my micrometer collar on my compound. I'm just going to turn it till it reads 0. You can loosen the set screw, but you don't really have to. Just turn it till it reads 0. The important thing here is you want to make sure that you're always screwing in on your final move, on either the cross slide or the compound, because of what's called backlash. If I go past 0 and I back up to 0, now when I go to make my cut, I don't know if you can hear that noise or not, but I pulled the backlash out of that. It kicked away. So what you want to do is back up beyond 0 and then bring it back to 0 without going past. So on 1, 0. Then I'm going to turn it on and bring the tool until it just makes a scratch cut. So I'm going to feed this in until it just lightly scratches the surface of the part. You'll see the part is wobbling a little bit, which it tends to do if you take it out of the chuck and put it back in. I'm just going to take a light scratch cut there, turn it off, and I'm going to zero my micrometer collar right there. So I'm going to rotate the micrometer collar so 0 lines up with my witness mark and tighten the set screw. Don't have to be super tight, just snug it. And now I'm going to position the tool at the beginning of the cut. Before you do that, you want to back the tool out. So you can use any number of turns you want. I usually use 2 turns. I'm going to grab the cross slide. I'm just going to back up 2 turns. 1, 2. They're really coarse threads. You might want to go with 3 or 4. But back it out 2. I'm going to move back to the beginning of the cut. In fact, I like to come back a little ways before the beginning. 1/4 inch, 1/2 inch. Now I'm going to take the cross slide. I'm going to go back in 2. 1 to 0 without going past. And we're always going to be at 0 for every cut of the thread. So I'm going to engage the 1/2 nut lever. I'm just going to pick a line and remember that line. You see I'm making a scratch cut. When you get to your relief cut, usually there's a groove at the end of your thread, and you disengage your 1/2 nut lever. What you're going to do is back that up 2 turns, your cross slide, 1, 2, bring your carriage back to the beginning, move your cross slide in, 1, 2, without going past 0, go ahead and turn it off. If I can time this right. Now if you notice it's cutting more on one side than the other, it's not uncommon for the part to wobble. When you take it out of the chuck and reposition it, the chucks aren't all that accurate, which is why you try to not reposition parts any more than you need to. Okay, so now you can see the scratch cut. At this point, even if this is wrong, we haven't scrapped the part, it's only a scratch cut. So now you're going to take your screw pitch gauge, which is in your toolbox, and you see these little leaves here? Little leaves, you're going to find the 13. We were shooting for 13. We're just going to check to make sure that the 13 does in fact line up with what we've done. Look at the first one, the last one, and all the ones in between look good. This is only used for checking pitch. It's not used for checking depth. So I'm done with this thing. I know I've got the lathe set right. I'll go ahead and put that away. To continue making a cut now, we know the pitch is right. First of all, this is all you need to do for your checkoff. You're going to take this part out, or you're going to call me over, show me, and I'll sign you off on your lathe stuff. Then you're going to take this part out, bring it over to the horizontal bandsaw, cut the part off. Actually, you can cut it off just before the threads in this case. Make sure you cut the center drill end off, and then somebody else can use it for their checkoff. To continue cutting this thread, you would feed with the compound. All the feed is done with the compound. So the compound is set at 29 degrees, so it's going to be feeding in at an angle. What that does is it keeps the cut entirely on the leading edge of the tool and not on the back edge of the tool. So you've cut your surface area of contact in half. And you can take about 4 to 5 thousandths of an inch at a time as you're making that cut. And I normally would be using oil to do this too. So let me just throw that on there so that's kind of in your head. Turn that on. Engage it on the same line, which I think was 4. Disengage, back it up 1, 2, back to the beginning, back in, 1, 2, without going past 0. Moving on your compound, another 4 or 5 thousandths. Engage it on that same line. Gotta wait for the threading dial to come around. If while you're threading, you engage the half nut lever, and it doesn't feel like it goes all the way down, abort before you get into the cut. You can always wait for that dial to come back around and make another cut. Otherwise, if you don't drop entirely into that, the half nut doesn't drop entirely down onto your part, you have to put a thread between where you want it to be and your scrappy part. I'll make a couple more cuts here. Maybe one more cut. Now the depth for a unified thread, if you take the formula of 0.708 divided by the number of threads per inch, that gives you the approximate compound travel. So right now my compound's at 15, and for a half 13, I think that comes out to be about 54,000. So you just go until that red, somewhere around 54. You want to check it before you get to 54. And before you check it, you want to deburr it, make sure everything's clean. But that's really more than what you need to do your checkoff. So that's threading. Next I want to show you the grooving and parting operations, at least the grooving end of it. This is a grooving tool or parting tool, and I'm going to install it. This tool, to set this tool up, there's two things you need to do. You need to get it square with the axis. There's a number of ways you can do that. One of them that I like to do is to bring this tool right up against the face of the chuck. And if you don't see any gaps there, it's all square. If you do, just loosen your tool post and adjust it until it's square. That looks square. Now, to put the groove where you want it, I would mic that tool even before I put it in and measure it, so you know how thick it is. If I come over to the end of the part, or where I want to reference my location from, I can bring that over until it just touches the end of the part. You can use a little piece of paper feeler gauge if you want, but I can, with these small lathes, I can pretty much feel when I touch. If I zero my digital readout right at this location, now my zero location is right here, when this edge of the tool touches that end of the part. So now if I wanted to put a groove that was maybe, let's see, 1 and 1.8 inches away, I just adjust my tool on my digital readout until I'm at 1.8. And I'm going to go ahead and lock my carriage. Don't forget to lock your carriage at the proper location. And that way it won't move in the middle of the cut. I slow my RPM down considerably more than what you would calculate. Again, this is a forming tool, so you're not just cutting with a single point, but you're cutting along an entire edge. So I've slowed that RPM down. Let's try 175. And you want to use oil with this operation. Everything wants to be very rigid. So I'm going to go ahead and turn that on. And you'll see as I start to feed this in, it's starting to form a groove. I like to keep the oil coming with this. The thing you want to do is you want to try to keep the chip forming all the time. You don't want to let it sit there and rub. Some materials will work hard if they rub. So I try to see a chip coming off that continuously. In fact, if I was doing this, I'd probably just hold the, I am doing it, but if I was doing it not trying to stay out of your way, I would hold that right there so it's continually giving it the oil. See that chip coming out there? And there's a groove. Now you can measure that with your digital calipers, and just like we turned down the diameter before, you can get that diameter right where you want it. If you want to part the piece off, you just continue going until you get to the center of the part. One caution about that though, if you're going to part a piece off, you always want to make sure that the tailstock is not supporting the workpiece when you do it. If the tailstock is there when that part's off, the piece will cock off sideways, it will bind up, and more than likely something's going to break. So whenever you're parting completely off, you always want to pull the tailstock away. I could part half, maybe 3/4 of the way through that part with the tailstock supporting. With that last little bit, you have to make sure that the tailstock is out of the way. So that's grooving. And also typically if you're cutting a thread, you're going to cut to a groove, and that groove, it's called a thread relief. It gives you a place to disengage your half nut. Grooving. One thing you should always do when you walk up to a lathe for the first time is try to determine whether it's a direct or indirect reading lathe. In other words, the numbers on this dial here, if you move this dial in 10 thousandths, does it take 10 thousandths off the diameter, or does the tool move 10 thousandths? Because if it moves 10 thousandths, it's going to take 20 thousandths off the diameter. Some people will tell you to rig up an indicator and all that. You really don't need to do that. Just look at the dial, figure out how far it is around the dial. It's 200 thousandths. That means 5 turns would be an inch. If I look here at the cross slide moving as I turn that dial, I'm just going to take and move that cross slide until it's flush on the end here, and put that on 0. Doesn't have to be perfectly flush, but somewhere in the ballpark. And then I'm going to turn this 5 turns, which is an inch. So I'm going to go 1, 2, 3, 4, 5 to 0. Now one of two things happened. Either this moved a half of an inch or it moved an inch. Most people can just look at that with their eyeball and they can see that it moved a half of an inch, which means if I dialed this in an inch, the tool moves a half of an inch, which means it takes off an inch on the diameter, which would be a pretty heavy cut. But it gives you the idea that whatever you dial in on here, that much is coming off on the diameter, as opposed to an indirect rating lathe where you'd have to cut that amount in half every time. If you don't do that and you're on an indirect reading lathe, you're going to undersize your parts. So that's the difference between a direct reading and indirect reading lathe. Okay, the 5 newest lathes have a few differences in them. I'll just point those out to you right now. They still turn on and off the same way in reverse, and you do still have the foot brake, and you still have the emergency stop. But the main differences here are the levers. For the feed, instead of having those knobs you pull and push, you have this one lever, and in order to lift up on it now, pull out, lift up, you have your longitudinal feed working. If you push in and go down, you have your cross feed working. So that one lever does them both. In and down is cross, out, up is longitudinal. Half nut levers and whatnot are the same. We do have We still have a carriage lock, but for the carriage lock, instead of using a wrench, there's a handle on here. So the handle's already in place. Then we have the quick change gearbox. That is slightly different. On the quick change gearbox here, one thing that's missing on this, or I should say that isn't here that's on the other lathe, is you don't have a selector between your lead screw and your feed rod. Whatever you have these handles and knobs set on, that determines whether the gearing goes to the lead screw or the feed rod. There is no separate knob there. First, let's look at the RPMs. So the RPMs is this chart right here. And let's say I wanted to set that on 325 RPM. So I see 325 right here, which is HLM. That's pretty straightforward. So we just put this on H, we go to L, we go to M. And just like with the other lathe, you might have to turn that a little bit by hand. You also do have the jog button. Something isn't quite in gear, so I know I've got, there it is, HLM, 325 RPM. That's not that different. Next, I'll show you how to set up the feeds or the threads, the thread cutting. And that's done with this chart over here. So let's look at the chart first. As we look at the chart, we have one for metric threads, which would mean changing the gears in the end of the headstock. We also have this chart here, which we're going to use most of the time for our feeds and thread cutting. That's the way the gears are configured currently. If I wanted 20 threads per inch, I can see that 20 is right here. So that would be B, C, 3. So if I see there's a B here, so if I throw that over to B, and then I want to find a C, and I have C is here, and let's see, that was 20, that was 3. Now, notice, this is good that this happened, because I can show you how to fix it. I can't turn that over to 3, it won't go. So one thing you can do is disengage the clutch, or disengage the gearing going to the lead screw and feed rod. If you turn that down there is no power going to the lead screw or the feed rod. That may allow you to turn this knob to the 3. In fact, it doesn't quite go, so I'm going to just jog a little bit, go back in gear, back out of gear, go back to, there it is, there's the 3. It can be a little tricky, but hopefully you'll get used to it. And then we wanted to go over to the C. And it should be all set. We have the B, C, and the 3 all set. And now we have to re-engage the output. And as I check, I can see that the lead screw is turning. So we're all set for cutting 20 threads per inch. Now setting up for feeds is the same with the knobs. It's done the same way. There is one other thing I should point out about that though. As you're looking at this chart, you can see that there are below the threads, you have a box that's split diagonally. The top left portion of that box gives you the feed rate in inches per revolution for longitudinal feeding. The lower right part of that box tells you at that same setting what the feed rate would be for cross feeds. So your cross feeds are roughly a third what your longitudinal feeds are. That's not all that unusual for a lathe actually. So if I wanted to set this up for say 3/1000ths of an inch per revolution on my longitudinal, that's 0.003 right there, that would be AF5. So you just set those knobs to AF5 like we did before, and the feed rod should be turning. Last thing on this, it's not really much different, is you have the feed reverse lever right there, changing the direction of the feeds. That points out some of the differences in the two lathes.